Next topic, fundamentals of analysis of an algorithm. In this, the issues analysis of algorithm, the issues first one, correctness, time efficiency, space efficiency, optimality. Optimality. These are the issues. Now, performance analysis of an algorithm. We can analyze the performance of an algorithm by using two ways. First, time complexity, space complexity. Time complexity. Time complexity means the amount of time that an algorithm requires for its execution is known as time complexity. So how much time that an algorithm requires for its execution, that is time complexity. In time complexity, three types. First one, best case time complexity, worst case time complexity, and average case time complexity. Best case time complexity. Best case time complexity means if an algorithm requires minimum amount of time for its execution. Okay, next, worst case, it is if its efficiency for the worst case input of size, and which is an input size for which the algorithm run the fastest among all possible input of that size, best of n. This is the best case time complexity. Next, worst case time complexity. Worst case efficiency is its efficiency for the worst case input of size n, which is an input of size n for which the algorithm runs the longest among all possible inputs of that size. If an algorithm requires minimum amount of time, if minimum amount of time for its execution, that is worst case time complexity. So the formula is C worst of n. Okay, next, best case, worst case. Next, average case time complexity. Average case time complexity means if an algorithm requires average amount of time, that is average case time complexity. Before that, what is in this the example, what is a, for example, linear search algorithm. It means searching elements of lines one by one until the key element is found or the some array is completed. The element of the list, for example, 10, 20, 30, 40, 50. Where as the key element is 40, then compare key element with elements of the array one by one until the key element is found or the array is exhausted or completed. Then we find the uh, key element, that is the average case time complexity. Okay, then worst case, these are the worst case, best case, and average case time complexity are the three types. Next, these are the formulas. Worst case, C of worst of n, maximum over inputs of size. Best case, C best, so minimum over input size, and average case, C average, and average over input size. Number of times the basic operation will be exhausted and typical input. So the average of worst and best expected number of basic operations considered as a random variable under sum of assumption about the probability distribution of all possible inputs. So average is equal to expected under uniform distribution. This is the worst case and best case and average case time complexity. Okay. Now algorithm. In algorithm, frequency count, step count, how to count the sequential searches. Algorithm search for given values in the given array, sequential search. Already I told about that. For example, 0, some numbers 10, 20, 30, 40. The sequential number, the key element is 40. Then until the key element is found, then only the algorithm finally result is search. Okay. Now next, is frequency count. Now, asymptotic notation. Asymptotic notation, what are actually in time complexity we have two types: basic, worst case, average case, and worst case. These all are the approaches. Now, asymptotic notation in big O notation, big omega notation, big theta notation. Normally, first I told about frequency count or step count. What is a frequency count? It specifies the number of times of a specific notations is to be executed. Here we can give the count value depends upon the statement. Count value means for comments declaration step count is 0. Next, return assignment step count is is 1. Next step is ignore lower order exponents. When higher order exponents is present, ignore the lower order exponents. Next, ignore constants. These are the four steps we are followed in frequency count. Okay, for what first one is for comments declaration step count is 0. Next step is return n. The assignment count is 1. Next, ignore lower order exponents when higher order exponents is present. Next one, ignore constants. These all are the four steps we can use for the frequency or step count. Next, the frequency count or step count, the time complexity, for example, order of n. Okay. Now, next, in next is asymptotic notation. In asymptotic notation, we are in formal language, the asymptotic notation mainly useful for calculate the time complexity in an algorithm. We have five types. Actually, we have the five types of asymptotic notation. First one, big O notation, big omega notation, big theta notation. These are the main three important notations, and other two are also little o notation, little omega notation. These are the five steps. Actually, big O notation, big omega notation, and big theta notation. Okay, first one, big O notation. Big O notation mainly represents big O notation. It is mainly represent the uppercase values. Next we'll continue. Thank you.